In the quadrilateral ABCD, AB is equal to AD. I'm just going to show this using these two blue lines. And AC is equal to DC. I'm purposely using colors rather than little kind of dashes, because if I put a dash there, how do I know whether it's AE that's equal to DC or AC? And furthermore, we've next got a statement about AE equaling EB. So E is where the diagonals meet, and then this is equal to this. So I think the colors make it a little bit clearer. Angle BAC is twice angle BDC, which is already indicated in the diagram, and we're asked to find the value of BDC. So that's x that we're trying to find, and hence prove that the triangle is isosceles. So let's use these facts to help us work out any angles. That's really the method here, and try and get an equation which we can solve to find x. We must give our reasoning along the way. So I'm going to be saying it out loud, but you should be writing it down if you're doing a written solution. So it must be that angle ABE is also 2x, since ABE is an isosceles triangle, the green lengths are the same. And then BAD is also isosceles, so I've also got a 2x over here. And then this angle, now I can focus on BAD. I've got 2x here, and I've got 2x here. It must be that this whole angle is 180 minus 4x. It's just because I've got a 2x there as well, then it's actually going to be 180 minus 6x. So that's me using the sum of the angles in a triangle in ABD. And here's the thing I can now use. I've not used the red isosceles triangle yet, but I can now, because it must be that this angle here is equal to this angle. If I draw this red triangle, I've got 3x, I've got 180 minus 6x, and I know that these two are the same. Therefore, base angles in the isosceles triangle equal 3x equals 180 minus 6x. So 180 equals 9x, x is equal to 20. And let me just clarify, that is angle BDC. Hence prove that ABC is isosceles. So I reckon at this point, quite a good idea is just to go back to the original diagram, really. Just going to add on the blue lengths. We had blue, blue, we had red, red, and then green, green. But now I can replace x by 20, 2x by 40. This is going to be 40. This is going to be 40. That there is going to be 60. So I've just filled in the angles I already had, but replaced x by the numbers. And I'm trying to show that ABC is isosceles. Now, there's a couple ways to do this. One would be to try and show that these two angles are the same, which actually ends up being pretty complicated. I'm not sure it's even possible. But the other way to get an isosceles, show that something is isosceles, is to show that two sides are the same. And I know we don't have any lengths, but if we can somehow show that AC is the same as AB, then we're done. And that is precisely, actually, you're only a couple of steps away, really, because it must be that this angle here is 60 degrees using the triangle ACD, because I've already got 60 and 60, so this must be 60. And therefore, triangle AED is actually equilateral. And that means that AD is equal to AC. The blue and the red lengths are the same. And therefore, AC is equal to AB, and that's all we need. So, triangle ABC is isosceles. Okay, don't worry if your solution's not quite as smooth as that. When I originally did it, I don't know why, but I introduced a y down here instead of 2x straight away. But I got to the angle of 20 for x, and then I played around with it. Actually tried to find as many angles as I could. I realized that it was never really going to work down here with the angles. So then I thought about what am I missing? Saw the equilateral triangle, and it all came together from there.